Today I'm going to create a program that animates a cart on a track using VPython. I'm not going to talk much as I add code, but I will add comments as I move along. So what I'm going to do is create two objects, a track and a cart that's going to ride more or less on the track. Now at this point, I'm going to run and just make sure these objects are where I want them to be and that I didn't do something too strange. Okay, and notice the cart's kind of a little floating up in the air, and it's a little bit too small. And I would really like it to start on this end of the track. So a little bit of editing needed here. I'm going to make the cart a little bit wider. And I'm going to start it a little bit back from the center. And so what I'll do is back the cart off by about 1 meter. And I also want it to go down a little bit. So we'll make that come down a little bit. And indeed, that looks a little bit better. Okay, what the loop does, what loops do is they continue to execute over and over again certain lines of code until a certain condition is met. And so what I'm going to do is I've set up some time variables, and I'm going to keep incrementing time until it reaches a maximum condition here, 4 seconds. So I'm thinking of a 4-second long experiment. And when time hits 4 seconds, we'll exit the loop. So what I do in the loop, there are two things that typically go into motion. One's called the momentum update, and it comes about because there's a force on your object. So you guys have been learning about the momentum principle, which relates change in momentum to force times delta time. So I'm going to have to include a force. And now I'm going to update the momentum of the cart using the momentum principle. So momentum is equal to what it was previously plus force times delta time, change in time. I'm also going to have to update the position of the cart, which will happen because of velocity. Now, notice up above, there's no variable that I've named. There's a momentum, but there's no cart position named. But notice that this object has within it an attribute known as its position. And to get at that attribute, I'm going to have to pick it out of this set of attributes. And the way I'll do that is built into VPython. It's with a dot. So cart.pos pulls this vector out of all the stuff inside of there. And it's that attribute that I want to change by using the velocity times delta time. So change in position is equal to velocity times change in time. Okay, last step So the loop looks finite, but all the commands that are indented beyond this while statement are just going to happen over and over again. Okay, so let's run this and see what happens. Okay, and we used the wrong variable name. Let's go back and check. Very common thing is to misspell something. Yes, I called it data time, and I really wanted to call it delta time. Okay, and notice things look really bad. All I see is the very tiny track buried in there. So something is wrong in the program, and notice there's no error messages. These are the hardest things to debug, but typically the way I do it is I will use print statements within my code to tell me whether I'm doing something wrong or right. But momentum's a pretty big quantity, so let me print out momentum and see what happens. And notice the program, in trying to tell me the momentum, says NaN, NaN, NaN. It's cussing at me, and basically NaN means not a number. So somehow my computation of momentum is messed up. So let's see what could have happened. Up at the top, I've made momentum a vector. So is there anything in this statement that is doing something wrong to a vector? And indeed there is. Vectors add, so this whole quantity, force times delta time, should be a vector, and notice I never set it equal to a vector. So there indeed is my problem. Let me turn force into a vector, which it should be. So I want to push this cart in the x direction with 1 Newton. I think that will work a little bit better. And indeed now I'm printing out momenta, but still things look a little bit funny. My green cart has flown way off the track and I never got to see the motion. So there is one particular statement I have forgotten in here, which is pretty important. This loop goes through the calculation so quickly you never really get a chance to see the objects redraw. So to slow down the loop, you can use a statement called rate, which controls how quickly or slowly the loop runs. What I usually put in for my rate is the inverse of delta time, meaning if your time is real small, your time increments, you'll run at a very fast rate. If your time increments are really large, you'll run at a slow rate. So let's run this, and much better. The total time does seem a little bit too long, so let's give it maybe 1.5 seconds. And that's about right.